talk about time signatures. And time signatures are important because composers generally, not always, but for most of the music we sing, composers organize the music into little boxes that we call measures. And those boxes all have a certain number of beats within them. And the time signature is what designates how many beats there are and how they get treated. So we're just going to start with the most common time signature. In fact, this time signature is so common that sometimes it's written this way with a C and called common time. So 4/4. So we have two numbers here. We have a number on the top, we have a number on the bottom. And they both signify different things. So the number on the top is telling us how many beats are in the measure. Or I should say the measure, in each measure. There's generally more than one. And a beat is just a basic unit of time. That's probably the best way to think of that. Now the bottom number tells us what note gets the beat. Gets the beat. So the beat is not a set thing that exists. The composer says what note gets the beat in each measure. In this case, this says number 4 gets the beat. That doesn't mean anything to us. So we have to go back to our note values that we learned before. We had whole notes, half notes, quarter notes, eighth notes, 16th notes. This 4 represents the quarter note. And each one of these has a number that is used in time signatures. So the whole note would be 1. I've actually never seen that, but it could be done. The half note is a 2, quarter note is 4, eighth note is 8, and the 16th note is 16. So that's kind of nice. It kind of jives up with the names that they have. So just as an example, just to throw some other time signatures out here, this would mean we still have 4 beats. We have the same amount of beats, but the 2 on the bottom means that the beat is the half note. So the difference between these two would be kind of half. So this is going over here now. A measure would look like this. We'd have 4 quarter notes. In 4/2, we would have 4 half notes. So that measure has twice as many note values as this one. We could say we had 3 eighth notes. And that would look like that. Well, pretty self-explanatory, 3 eighth notes, right? That one's easy. So that's how you decipher these time signatures. Now, to go into some more fancy theoretical terminology, I want to talk about simple meter versus compound meter. And this is pretty important. It's not important that you remember the words simple and compound, but it's important to remember the principles that underlie them. So basically what we're designating when we call a meter simple or compound is we're referring to how the individual beat, in this case, we'll take this. This is an individual beat. The beat here is a quarter note. Simple versus compound, we are talking about how we can divide this beat even further. In simple, we're saying that the beat gets divided in 2. Divided in 2. And in compound, we're saying that the beat gets divided in 3. So, and I'm going to show what this all means. By the way, just from the get-go, a nice, helpful shortcut to know whether you're in simple or compound is if your top number is a 2, 3, or a 4, you're in simple meter. If your top number is a 6, a 9, or a 12, you are in compound. Okay? So, let's go through some examples. Let's start with 2/4. So what does this mean? This means I have 2 beats in a measure, and I have, the quarter note gets the beat. So that would look like this. I'm going to introduce another thing. In addition to simple and compound, we can designate whether our meter is duple, triple, or quadruple. And the reason I started with 2/4 is because this is an example of simple duple. The duple means that there are 2 beats in a measure. And the simple means that those beats are divided in 2. So because this is simple, if we start using smaller beats than our quarter note, like eighth notes, there's going to be 2 eighth notes for every quarter note. That's what makes it simple. So this is an example of simple duple. 3/4, we're going to have 3 quarter notes. This is an example of simple triple. So the triple refers to the number of beats in a measure, and the simple refers to the fact that if we divide this individual beat, we'll get 2 more beats, eighth notes. And I'm not going to write this one out, but 4/4 is going to be simple quadruple. Right? My beautiful, beautiful handwriting. Okay, the quadruple meaning that there's 4, I guess I will draw it out, 4 in each measure, and then an individual note will be divided into eighth notes. So this is what we're probably most familiar with. However, compound is important, and it's important to know when we're in it. So again, compound, we're going to have 6, 9, and 12 in the top. So let's start with 6. 6, 8. Probably seen this time signature before. This means that we have 6 eighth notes. But hang on a second. Look at this. Look at this measure. This is also 6 eighth notes. It's equal to 6 eighth notes, I should say. So what is the difference between 3/4 and 6/8 if they have the same number of beats in each measure? What's different is how we divide the basic beat. You wouldn't see a measure like this in 6/8 because these are divisible into 2. 6/8 comes in groups of 3, which means if we were going to take that up a level, our basic beat actually becomes the dotted quarter. But rather than writing this like this, although sometimes it's helpful to think of 6/8 this way, that your basic beat is 2 dotted quarter notes. 1 and a 2 and a 1 and a 2 and a. You could count 1, 2, 3, 4, 5, 6, but I don't know, it's a lot of numbers. And really, we feel the beat here. So it's 1 and a 2 and a. And you wouldn't know that just by looking at this, something you would have to learn. So this is an example of compound duple. The duple because there's 2 basic beats in each measure, and compound because an individual beat gets divided into 3. 9/8 is going to be pretty much the same thing, but we're going to have 3 groups of 3 instead of 2 groups of 3. So that's a measure of 9/8, or that is a measure of 9/8. And 9/8 is an example of compound triple. Because the triple meaning that there's 3 in each measure, the compound meaning that there's 3 within each beat, right? And then 12/8, right? Those are eighth notes. Beautiful, beautiful eighth notes. Okay. Now we have 1, 2, 3, 4 groups. So this is compound quadruple. Again, I know I already said this, but it's not that important to remember. We've learned 6 terms here. Simple duple, simple triple, simple quadruple, compound duple, compound triple, compound quadruple. It's not super necessary to memorize that, but it's important to understand the concept, the difference between simple and compound. And to remember that when you have a 6, a 9, or a 12 in the numerator, I guess we'll call it, the top number, we are in compound meter, meaning that our basic beat is in divisions of 3. And when we have 2, 3, and 4, they're in divisions of 2. I should also mention, I used 4 for all my simple examples and 8 for all my compound examples. It doesn't have to be that way, though. I'll write these right next to it. You could also have 2, 8, or 2, 2. You could have 3, 8, 3, 2. This just means that instead of, take the top example, 2, 2, you would have 2 half notes. But that's still simple duple, because you have 2 of your basic beat, and those half notes are going to be divided into 2. So the bottom number doesn't really matter in designating between simple and compound. It's all about the top number. You could have 6, 4, 6, 2. So the thing to remember about 6, 4 is that like you're going to have 6 quarter notes in a measure, right? But they're going to be in this kind of beat pattern. And so your basic beat is going to be that. So it's not going to be 1, 2, 3, 1 and 2 and 3, and we're like 1, 2, 3, 4, 5, 6. Your beat isn't there. Your beat is there. That's important to know. And the way we know that is because there's a 6 on top. 9, 4, 12, 4. Again, just pointing out that the bottom number can be anything. That's just changing the basic unit that you have. The top number tells you how you're dividing it. So that's enough for today. Next time we will look at actual examples of music, look at how to write in counts based on all this information, the note values in conjunction with time signatures, and how the notes all work in a piece of music. So until next time.